Hello, everyone. My name is Anton Titov. As being announced, I'm also founder and CEO of company Spiral Scout. I'm working on PHP and Golang for the last 16 years, obviously Golang less. And by accident, I'm also the author of a number of open source instruments such as Spiral Framework, Roadrunner, Cyclorium, and Temporal PHP SDK, which I'm going to describe in today's presentation. What I'm going to be talking today is a number of topics. Number one, I'll explain what is business process orchestration workflows are, how you can create a fault-tolerant system, which else is scalable. I'll provide a quick review of the Temporal.io solution, which they provide for the world and for the community for free. I will explain how you can create and define workflow orchestration process inside the PHP things. And just to make it a bit more fun, I'll show how you can actually sleep PHP products for 40 days without losing a bit of data. To start, let's probably start with a bit simpler example and walk through the process. Imagine a situation that your company decided to, well, start selling pizza and delivering that. So your manager comes to you and say, hey, let's design a process and develop an application which will allow us to manage this whole process. You know that this process is going to take a while. It's not 2 seconds to cook the pizza and deliver that. So, okay, we're going to use most likely database to keep the state of the order and some queuing solution, let's say RabbitMQ, to actually send the task to part of the application responsible for that. First, what we do? Well, we're doing the first integration, let's say, with Uber Eats. So we have a queue which creates another task. These tasks sent to the Uber Eats API, get the tracking code, sent to customer. Everyone is happy. Well, next thing, what is going to happen is that your customers are going to ask you can actually see the state of the order in a bit more details. That's no problem. We have a terminal in our kitchen, so let's have additional queue, maybe additional endpoint to send a task to the kitchen, wait for the cook to hit the button, I accept the order, wait for the cook to hit the button, I cook the order, and then we can continue the process. Well, the problem was that Uber Eats apparently not so cheap service to deliver. So the management decided, okay, for this specific neighborhood, let's use a local service. They provide cheaper rates, but the problem is they actually don't use a classic API. Instead of they're going to send you data back via callback or webhook. Fine, we're just going to create a custom API endpoint, accept this webhook back to us, and just continue the process. What we didn't know that in separate department inside the same company, different team was actually developing their own delivery service, their own backend. So you've been tasked to integrate the service to your system, which is fine. It's just additional task queue, additional process step. It's going to work fine. Kind of, because what you didn't know that the service was created yesterday, and it kind of prone to errors and fails. That's okay, not a problem. We're going to add possibly some protection around retries. We will create a separate cron job to actually check if you got the response in time and maybe restart it. It's okay. I mean, by now we know that it's probably not going to look very beautiful. Later we found out that our cooks actually love watching football game and sometimes they forget to accept the order. Fine, that's normal, I guess. Let's add a timeout, and on this timeout, let's send the email to the manager. We're going to do the same for the cook which forgot to click complete order, and it looks fine. Like, I think we've done our process. The only last step which left is when our customer asks us, can we actually cancel the order? And we do know that we cannot cancel the order which already in delivery or already in oven. So we're probably going to add additional endpoint and additional switch somewhere around accepting the order to make sure that you cannot accept it if it's been canceled. What we have at the end, well, we have a beautiful system built at top of the queues and databases with a lot of hard-coded API endpoints, custom connectors, and etc. It works fine. However, it is prone to the errors in the scaling, and in a bit later stages, I will explain why is that. So what you just seen on this picture is called the business process workflow, and the process of automating this process or coordinating different tasks inside this process called orchestration. So now let's probably jump in a bit more pure definition of this process. And just to be clear, there is many different definitions of what workflow is. I will try to use my own. It might be a bit different, which you might hear somewhere else, but I mean, they're all pretty much the same. So what is a workflow? The workflow is indeed a program. It is simply the sequence of tasks which you want to execute. Practically speaking, everything is a workflow, but just to make it a bit more concrete, we are saying that workflow is something which contains simple coordination logic, or logic which is easy to describe. In our case, it can be, let's say, a picture. So like this picture describes you the workflow, which definition or like next command or what to do located inside the workflow definition section, and actual activities or tasks, this task 1 and task 2. Important aspect of the workflow in the real world that they should A, react to external events. For example, someone want to cancel it or someone want to add additional papers to the pizza, and B, they should be long running. The real world events, they typically span across minutes, hours, or days, and months. So it's not convenient to automate it using something which is only can reliably work for a couple seconds. Important aspects for the real workflows, for the which provide actually useful abstraction, is to make sure that they are observable and durable. What observability is? Well, observability is the ability to actually understand the current state of the workflow. Where is your pizza now? You don't want to order pizza and then just trying to guess if it's going to arrive in 45 minutes or not. You want to read the execution result. You want to be able to possibly search for the workflows which are already running or being stopped. And most likely, you also want to understand audit logs. What happened? Why delivery took so long? Why cooking took so long? To understand how to improve your business process. Durability, on another end, is a much broader topic. Typically, what it means when I'm saying error equals error is that you want to build a system which would never hide the actual error from you. You don't want to tell customer, hey, your order can't be delivered because we don't know what happened, just stuck. You want to understand that you send the message to the worker didn't handle that, it failed, because of that it been timeout, and because of that the main process failed. So you need to have a very clear system which propagates errors correctly. You also need a number of primitives such as timeouts and retries to actually build your logic and make sure that some real-world failures, and they are going to be happening, can be handled correctly. And most importantly, you want to understand the errors from their source to the point when this error actually failed your work. Where you actually use workflows or durable workflows? Well, in many places. It can be document workflows, infrastructure management, file processing is a very popular thing, monitoring, CI/CD, financial operations, anything, you name it. Practically, once you start seeing workflows, you will start seeing them everywhere. If you have to orchestrate or automate a number of steps in a large application, that's most likely going to be a workflow if you want to make it durable and observable. So let's think how we can actually implement something like that inside our application or PHP application. Well, option number one is go to naive direction and just do it by yourself. You can use queues just to distribute the load and execute tasks in different parts of your application. You can use database or Redis just to propagate the state, so you know what the current position inside the workflow is. It's up to you how you're going to orchestrate it. It can be JSON config. It can be the logic which is partially located in different task points. Overall, you're going to be dealing with a lot of edge cases, some of them related to scalability, some of them related to durability. Specifically, the problem which you're going to be dealing with is a problem around keeping the consistent data or transactions across different backends, which is databases and queues. In a bit later stage, I'll explain how Temporal deals with that. You can go to a bit more advanced solution and use Kafka. It's a beautiful solution for systems like that. It's all event driven. It has essentially audit log by default, very well scalable solution. Most likely you're going to be using distributed coordination, which means your next step is going to be assigned to the specific task. So it's know what to do next. In some cases, you might have the common kind of orchestrator microservice. The problem is, well, it's a lot of in-house code, and by now I don't know a single recipe how to build a workflow system at top of Kafka. Pretty much everyone is building their own custom solution for their own custom needs. So it's not something you can adapt very quickly. Another approach is fine, let's just forget about it and just buy something or download something. It's a ton of solutions which provide you declarative approach. Declarative means that you add the using configuration, maybe YAML file, maybe Visual Builder. It's a Netflix conductor, Apache Airflow, Camunda, Amazon step functions, and etc. This is legit solution. However, they do tend to have a lot of specific limitations. Number one, under the hood, it's a finite state machine, which means it can only do what it was kind of designed in a graph. If you want to have some dynamic branching or dynamic resizing, well, it's going to be pretty complicated. They all tend to go to their own custom DSLs, so you have to study and learn this DSL for yourself. Some of them proprietary, some of them open source, but they do require you to set up a number of infrastructure endpoints to actually make it work. An important thing is that they also have limited mapping capabilities, because all of the data mapping happens inside their engine, so you only can map data based on the rules they provide you. In some cases, it could be some extensions, but generally speaking, engines like that typically have a lot of high-level limitations. So when we was tasked to bring workflow engines or orchestration engines to our stack, we kind of become a bit depressed, because in-house solution, so the custom solution for the project, is going to take a ton of time, and we have to deal with the same exact issues with durability, scalability, losing events, getting queues stuck as any other people on the market. Using existing engines either means using proprietary or paid SaaS solution, or studying the DSL code, which, well, typically just unique thing for every new engine. So integrating that to the small project was a bit overhead. But then one day we found the product created by Uber company, and it's been called Uber Cadence. So this product has one very unique feature. Essentially, they do not have the DSL, and they allow you to orchestrate or write the workflow definition purely in your code. In their case, it was Golang and Java. You can literally code your next steps as just typical program, except it is going to work in durable fashion, and it's going to scale almost infinitely, well, as they claim. But seeing on Uber and the people who use this engine, it's kind of pretty much believable. They also have a Golang core and Golang SDK, which is good for us because we have a product named Roadrunner. So it's going to open the path for us to integrate it to PHP work. What we found later, that authors of Temporal actually authors of Cadence forked it into a separate company, got some investment, and released everything under MIT license. So it's kind of free to use for any size of the project. We've been able to communicate with them, so they even actually helped us to build this integration to PHP, and they exposed a number of internal API endpoints to make this integration slick. So let's talk about Temporal just a bit, just to show you who are behind this engine. So Temporal actually started many years ago. One of the authors of this engine is one of the developers of Amazon Cloud Instruments, specifically SQS, SNS, and SWF. So he has experience with workflow engines back in the day, and engines which currently drive, well, I would say, significant portions of the internet. Another author, this guy name is Maxim. Sorry for not mentioning that earlier. Another guy, Samar, was doing kind of similar thing, which is service bus and durable functions in Azure. So it's been kind of interesting way. They built it, and then they met both on Uber and created Cadence. And then in 2019, a few years ago, they created a new company called Temporal, forked Cadence, fixed a lot of bugs, polished the engine, and released it for the world to use. Who uses that? Well, a lot of companies. You can probably Google testimonials, but obviously it's used by Uber, and Uber is a pretty big company. Specifically, they orchestrate all of the financial processes inside Uber using Cadence or Temporal. Checkerbox, and if you guys know HashiCorp or HashiStack, they use Temporal under the hood as well. Okay, so how does it work? Let's take a look on this workflow image once again, and you'll see on the left, this is Temporal workflow definition, and there is a tasks. So what Temporal is doing, it actually asks your workflow definition, your code base, what to do next. So this engine kind of communicates and it asks, okay, what's the next command? What's the next task? Taking this task and send this task for the activity to execute. Well, practically, it's a bit more complicated because Temporal also are going to load balance this task. So it's going to take it, put into the queue subsystem, going to have some partition and sharding. It's going to load balance it to available worker, and it's also going to add a number of timeouts. So every time you register activity, you automatically register an additional timeout, which is going to verify the activity either always executed or failed. So from your engineering perspective, just as developer, all you do is just saying, hey, I want to execute tasks. So that's what you can see on the left part of the screen. Or you're just saying, hey, I want to make next decision, and that's called a workflow task. Under the hood, what's happened, you actually register this information into common audit log, into common database, schedule that to multiple queues, schedule a timer for that, and then load balance the result and get the result back. So it's a lot of things happening under the hood, but for you, it's just a simple task execution. I will show later examples done in PHP how it looks like. And it kind of seems easy, like why not? You just take an engine, and that's kind of what we describe doing custom database, queues, and here we go. Well, the problem is, and problem number one is that it should take me 30 minutes to describe this slide, but I'm only going to spend 1 or 2. The problem you have is to actually keep consistency in engines like that, because the Morpholow here on a scale is going to play a very bad trick with you. Because you have to register data in multiple things in database and queues, you have to make sure that all of this data registration can be done consistently within the single transaction. Because let's imagine the situation. We have to write the information to RabbitMQ and to database, and we're going to open database transaction, write data to queue, and then, well, commit transaction to database. Well, what may happen here is that we successfully send data to queue, but transaction failed to our database, and now we have a task which is floating within the system with no notion of what actually should be done because the state hasn't been saved. Okay, let's try to do the different way. Write to the database first, commit transaction, and then write to queue. In this case, if writing to the queue is going to fail, you're going to have the state updated, but you're never going to have task delivered. And in this case, the system will just stuck, so you'll have no idea what's going on. The problem is when you orchestrate real processes, you have a lot of tasks, up to millions. So things like that will happen, some network timeout, some database failure, and etc. So how to deal with that? Well, typically, we can solve this problem using an approach which is called two-phase commit. The problem is people who actually work with two-phase commit and try to solve the problem with them probably know that once you use two-phase commits, you now have not a single problem, but 2 problems because they are not so easy to implement and scale. What Temporal does here, well, they do a very simple trick and a very elegant trick. They're using the pattern which is called transactional outbox. Specifically, what it means that when you write information to the state and to the queues, you don't write them to the queues directly. You write them to your database inside a single transaction, so you can register multiple actions, timers, and queues within the single atomic operation. And then in the background, you read out these operations from outbox table to your queue provider. In this case, you guarantee at least once, and you guarantee that all the data is going to be consistently written into a single database. The only downside in such approach is that the message will arrive to the message broker or queue solution on a bit later stage, maybe like additional 100 milliseconds delay. Typically, it's not that problematic, but it might be a trick in very, very specific use cases. So what essentially Temporal provide you, they provide you the approach which called write-ahead log. They write all the history and all the requests which your workflow is asking it, like I want to do some action, inside the database, inside the history log. Because you have this history log atomically written into database, you have full proof of the work done till this point. So even if you have a full power outage, you will know from which point workflow failed and you can recover it. I'll show how the recovery happens in PHP on a bit later slides. From the infrastructure perspective, obviously it's not a single binary, but it could be. You can actually pack Temporal into single kind of executable file. You can put it into Docker, or you can roll up to a Kubernetes cluster using Helms they provide. It has a number of subsystems, historical, sharding, matching system, front ends, internal workers. It also has out-of-the-box integration to Elasticsearch if you want to materialize some of the workflows, which is very good when you want to search for them. And it can work at top of your already existing database, specifically Cassandra, MySQL, or PostgreSQL. So you can use any of them to make a solution work. If you want to go global, I personally don't, you can set up multi-cluster. It probably won't be that easy, but you can probably consult with Temporal team how to do that. In addition to that, they also provide a nice UI, which allows you to actually view this internal history of the workflow and understand what happened. Hey, we want to set up the task was timed out, it caused this error, which caused that error, and etc. Okay, so that's been the Temporal engine, and let's probably view what can we do with PHP. So what we had on our hands to make this integration work. Number one, we obviously had the Temporal Golang SDK, which actually handles pretty much all of the coordination work, and it's been beautiful for us because we saved a few years of engineering. Temporal team specifically opened for us internal API, which allow us to hook into the engine on much deeper layer. We'll have a transport layer to communicate between the process and workers using Gorich protocol and protobuf. We used React PHP promises to actually build a sync PHP base to write the workflow definitions. All of the workflows, they are async. And we use Roadrunner version 2 as primary engine to supervise all of that and glue it all together. So how does it look? Well, the simple picture looks like that. You have the Temporal server, which coordinates with Roadrunner, which runs Temporal worker inside, and through mapping layer, it communicates with a number of workers for the activities or for workflow definitions. It's all async PHP for the workflows. For the activities, you can use classic code. We pack number of workflows inside a single process, so it's pretty much conservative on memory usage. We have a number of layers which actually handle errors. We handle errors in PHP, in Golang SDK, and Roadrunner, and Temporal servers. So like if something fails, we will know that it failed. Obviously, because we write in PHP, we have hot reload, so you can debug your application as you typically do, load balancing, and we also have a full data isolation. What it means that the actual mapping, the actual data processing, all of that thing happens in PHP workers. And if you want, you can actually encrypt the payload which you send to Temporal server, which is very critical for this when you use Temporal as SaaS or when you write some kind of enterprise application. So what are your main building blocks when you use Temporal in PHP? The building block number one, and it's your main kind of workhorse, is activity. Activity is simply an interface with number of methods and attribute or annotation for that. You can use both, or it's a class. Practically speaking, it's just a method of the class which you want to invoke with some parameters in and get some result out. It can be anything inside. This code is executed in a blocking fashion as any other PHP inside your application. So you can use Doctrine inside it, you can use file processing, anything you want to use, you can use here. There is no limitations. Fun thing is that you can also use activities from different languages because Temporal out of the box support Golang and Java. So inside your application, you can use many different microservices in different languages. Going forward, they're going to add more languages for the support. And then you have a workflow. This is how workflow looks inside your application. Again, it's a class with attribute. I'm going to zoom in at the internal part just to make it a bit easier to see. This is async PHP code, so you have to use yield to wait for the result. You cannot use, well, classic PHP blocking functions here because, again, it's async PHP. You can't use IO because this code should be deterministic, and deterministic means that the behavior of the workflow and the tasks and activities it is doing should be consistent with only the input of the workflow. Like, it cannot depend on some random configuration or time of the day. It should always be consistent, and there is a very important reason for that. And this reason is durability. So, like, let's take a look at this code. What this code is doing, it is defining the activity based on activity interface. That's to make it easier to basically port, so you can just expose interfaces between different microservices. We start to close timeout of 600 seconds. Then it is executing activity say hi, activity say bye after that, and then return the glued result. Activities say hi and say bye will be executed in different workers, in different process, or maybe on different machine. And it might take, well, minutes to actually get to there, depends on what's inside your code. But this thing is durable. How is that possible? Let's imagine a situation that you executed activity high and then the power went off. There is worker is dead, nothing is happening. How can it work? Well, that's probably most of the magic of Temporal. What is going to happen? Temporal is going to recreate its workflow when the new worker will be available or on different machine, and it's going to replay this workflow till activity high. However, instead of executing this activity again, it is going to get already existing result of this activity from the history. So from your code perspective, it just looks like a single program. Practically, this program is going to be run twice. First time it fails, and second time it is going to run till the point of failure, just replaying the thing without doing actual work, and then it will continue doing by process. This allows you to create workflows which actually can be sleeping or be down for hours, and you can continue from this exact point. There is no data serialization. You just recover the state by replaying the steps. What else do we have in PHP SDK from the workflow perspective? Well, obviously, because it is async PHP, we can have async tasks. This is two examples. In example number one, we scheduled two activities, hello and bye, and then we blocked on hello, but bye at this moment already been scheduled as well. So we're basically going to be waiting for two activities at the same time. You can also use React PHP primitives, and you can schedule a number of activities, let's say in an array, and then wait for any of them, or wait for all of them to complete. So feel free to use your own abstractions. We have coroutines. What you can do, you can create a function inside your workflow. It's called workflow async. And inside this function, you can use the same primitives like activities, passing variables, yielding, and waiting. However, this coroutine is going to be executed in the background of your process. And when you want to get result of this coroutine, you just do yield on that. So between setting the coroutine and between doing yield, you can do something else, maybe run other coroutines or run nested coroutines. You also have timers, and timers are extremely valuable here because you can sleep for almost any interval, almost a year. In this example, what we do, we set a value of just variable to 0, and then we sleep for 1 minute. Then we do some activity, add a value, and then we sleep for another 1 minute. What is going to happen under the hood? If Temporal will see that the worker is sleeping, your process is sleeping for a long time, it is probably going to offload it from memory so you don't kind of consume resources for something which is not moving. And when the timer is going to be fired by the Temporal server, it is going to recover the workflow and replay the state to the moment of timer definition. So this way you can actually sleep for real for like 30 days. Another important abstraction which Temporal provides for engineers, and this is something which mostly comes from the world of the workflow orchestration, not from the world of typical code writing, is cancellations. Imagine that you run a large process with number of steps, and someone just say, "Hey, I actually don't need it. I want to stop it." Now, what you want to do, you want to actually cancel all of the activities which are already running and prevent new activities from execution. So for this operation, we have the cancel feature available for coroutines and for the workflow. And in this specific example, we actually run the coroutine. We execute a number of activities, like all in parallel. As you can see, we do not yield on a single activity. Then we wait for the first number of activities to complete, and then we cancel the rest. There is an example in Temporal repositories which you can actually observe this behavior by yourself. In addition to that, we have signals. So signals, they're actually just methods inside your workflow. They are eventually consistent methods. They allow you to add or modify workflow as it goes, just as kind of executing the code. In this example, we have a single method which simply adds a value to the input, just an array, and another one which sets exit to the true. So you can use that to actually receive values from the user as we go. For example, add credits to subscription or do something else. This example is a bit more complicated, but take a look at that. We have while true. It's a real infinite loop. Inside this loop, we are waiting for the input not to be empty or for the exit command. And if input is empty and exit command happen, we just, well, exit. If not, we're actually going to process this input as we go. This example is better to actually play by yourself in examples Temporal provided for PHP SDK, but it's actually a very powerful way to emulate how you can create infinite process inside your memory and communicate with it as we go. Like you can actually send input to this workflow a year after you actually created the actual workflow. This thing actually extremely useful for things like aggregated transactions when you want to send money from multiple sources to a single, let's say, receiver. Another thing you have is queues. Queues are, again, just methods of your workflow, and they allow you to read any of the variables or properties of this workflow. They cannot allow you to modify it, but just read. So in this case, we have this query greeting method, which just returns the value of the message or the property message. Inside our workflow, we just set it to hello, wait for 20 seconds, and then set it to bye. So inside this workflow execution, for the first 20 seconds, you will read as hello, and then you'll read as a bye. The beautiful part is that you can query workflows after they've been completed and still like in history. So this is useful to get values from existing things. And you can also have function to materialize some of these values as you go in Elasticsearch, or I think MySQL as well. So like while you go with workflow, you can actually update some values for the easier fetching from some simple source. You also can create infinite and periodic workflows or cron jobs here. Again, in this case, we have a while true, and this is the workflow which creates a subscription model. Specifically, it sends a welcome email, then waits for 30 days, charge fee, send another email, and then again waits for 30 days. If user will say, I want to cancel subscription, then we're going to run, process of canceling subscription and bye-bye email. This is a whole process which is required to orchestrate the subscription, maybe with or without trial period for the single user. If you remember how this typical process, how long it takes to create from scratch using cron jobs and queues, you'll be surprised that there is just literally like 4-6 lines of code to do it here. Essentially, what Temporal is doing, they allows you to use single cron job for the user instead of one large cron job for all the users. And you can have like millions of these cron jobs. You also have cascade error handling, so you can use classical try-catch. You can catch timeouts, failures, you can understand and read the stack traces. What we built inside, we built the ability to actually glue the stack traces from different languages. So if you have the workflow in Java, which executes workflow in PHP, which calls the activity in Golang, you will see actually the full stack trace from all the languages with all the files involved into the error. Obviously, because we have try-catches and because we have activities and a way to durably run them, you also have sagas, like this classic saga pattern with compensation. Typically, you can do it on queues, maybe Kafka, but here, saga is just a helper class. It's not even part of the server, it's just part of the SDK, and inside it's like 100 lines of code. all it is doing is executes the activity and then just adds compensation. When you have an exception and you run Saga compensate, it's simply just playing all of the activities you want to compensate, and all runs in durable fashion. If you want, you can create your own Saga implementation simply because it's just super easy working with these base abstractions directly in your code. So what's next for this SDK? It's currently in version number 1. And in version 1.1, we plan to also add additional test framework and activity mocks. Right now, unfortunately, you can only test it in integration fashion, which is fine for most of the tasks, but might be problematic for the long-running workflows. We want to provide dynamic task routing so you can extend it a bit easier for your own purposes, local activities for a bit more smaller tasks, and some performance optimizations. It's not like it's working slow now, it works great, but we see a number of points which we can improve it on. In the future roadmap, we also want to provide more examples. You already can find a number of simple things you can do with that in examples folder, and there is also interesting application done by Temporal staff, which actually demonstrates how to play snake game using 3 languages at the same time. I think they use Java to draw the snake, Golang to capture the input commands, and PHP to actually operate as a workflow orchestrator for the snake and just move on the screen. It's kind of amazing example how you can use multi-stack for things like that. We're going to provide Temporal SDK in our framework out of the box in 2.9 version. As we said, local activities. We also want to provide sticky session support, which is very valuable function for someone who wants to process files. It will allow you to run a number of activities on a single server without re-downloading file between the steps. And we also want to have an embedded Temporal server, just a small one, inside the Roadrunner, so you don't even need to install Docker to make it work. If you want to try it, well, there is a number of documentations and examples on their website and GitHub. There is a template project. If you can speak Russian, there is a workshop, which I think takes around 3 hours, how to write Temporal. And there is a number of references which you can dig and check around how to use this tool. I think that's it on my side. Thank you for your attention.